Alright, given that you followed what we've talked about till now, or you are just curious a little bit more about um, what C++ can offer and why are we studying it, etc., we'll continue discussing about functions, methods, and why they are important, how are they connected with memory, how are they used, what do they actually do, and so on. So let's get straight to it um, uh, without spending more time just on theory. But before that, I just want to mention a few things that you do have to know a certain amount of things and prior knowledge to what we'll be talking, because once again, even though we'll be covering only the surface of everything, that is, looked in depth in university, etc. This is a course from computer science, and we are looking a little bit on the surface, but also just running through different terminology and basics. So do keep in mind that if you don't understand something, you should definitely look it up, because it won't get much easier. So we will discuss what methods is, what a function is. Also, this is going to be in C++, and method functions, higher order functions, predicates, Kate functions, and we'll also talk a little bit about recursion, and not only recursion, but what recursive structures there are. So let's go straight to it. So what is a method and what is a function? So basically, a function, as we already discussed, its main purpose is to a sequence of operations with maybe input that gets an output. Well, there's definitely a much better explanation, but let's stick to that. So a function that we already mentioned earlier is a type of sequence that, given we have the memory with stack and heap, it allocates a certain amount of memory, and it requires a certain amount of steps that do a certain amount of logic and returns value. So each and every function definitely has a type of the return value. So type, I'm not going to write anything like that, because I believe it's much more type and then variable name and then curly braces, and etc, etc, etc. What I'm going to write is basically straight examples, such as, for example, we have a given type, which might be, for example, int, then we, which is the returned value of type, then we have the variable name, which might be just my first, really my function, which is name. Then we have the curly braces, and of course what we have are a list of variables, for example, and their decorations. So dec of, for example, int and the name and etc. And of course we have the body, and we have everything there is for now. So all right, so we've already mentioned that these are the formal parameters, because this is the declaration of a function. So the declaration of a function basically is where we declare it and we write its basically functionality. So when we call a function, so given that this is the way our code is run, so from top to bottom, when it gets to a certain place, for example, here we have declared some sort of variables and so on, we get to the point where we want to call our function, which is called my function. Well, this my function, here is the stack, and it has declared some things. We get to this point and it creates a new kind of place for running the function. So when the function ends, it closes this body that has been opened, and the memory inside the computer continues with the next processes, which are basically if we have other functions, and then return if we have, for example, to summarize something and get a result, and so on. So everything that we have done inside this function, we already mentioned earlier, will be lost in terms of parameters and their variables, unless we pass them by reference and so on. Or if we just want to return something like each and every time we want to get the time, well, then we definitely don't need to have references to anything, because the time would be different each and every time, and we just want to have the current time. All right, so enough about functions. So this is what they are. So let's take a look at what a method is. So a method is something a little bit more different than you might have expected, or if you are familiar with it. A method is a function that is part of a class. Part of a class. So now we have to explain what a class is. So you're familiar with the fact that we've talked about a little bit about variables. So a class is something that can contain different types of variables and data structures. Basically. So a class can be a container that can contain basically container that can contain different different type of uh, data, which can be int, double, and so on. It's just like an array. You already know what an array is. So imagine a class being an array that can contain not only one data type, but different data types. Data type list. So you can have a list with integers, then you can have a list of other variables like characters, and even what is a string. Well, a string is actually a class. So a class can contain other classes as well. Okay, let's remove this. Okay. All right, so we said the basics about what a method is and what a function is. So just before we switch to higher order functions, a method, part of a class. There is also, we just have to explain what a class is a little bit more. So there is also struct, which they're pretty much the same, class and struct, and how they define. So class and struct, and then you explain what you want to have inside the body of a class or a struct. So you have int, intig, we want to have double, double, and so on. And then we can have, of course, here we have the name of the class. And for example, if we want to this to be our double double, this is the variable in integer. If you want to return a certain amount, for example, we want to return just the number of of something, like in kilograms or miles, and sometimes we might need it the exact miles, but if we are going to use it as something just to show that we've reached a point, like on a kilometer of a car, we don't want the user to see, okay, you have gas for exactly 4.4, then you can see 4.3, then 4.2. You would only want to see a certain amount of integer. So easy as it is. So method classes. So what is the difference between a class and a struct? That class, everything by default is private, whereas in struct everything by default is public. This might not sound like a lot for now, but we'll get to there as well without getting too deep into it. But that's good for now for you to understand. And methods are actually the interface, so the public methods are the interface of and interfaces of actual class. So what the class can actually do. So hopefully that made some sense. If not, please feel free to ask me in the comment section. Yeah, I can explain it a little bit in depth as well, but let's not let's not waste time with classes in general for now. Let's just explain what higher order functions are and what do they do. So a higher order function is a function that, for example, void function that returns us nothing, but we want something to happen inside. For example, we want to add or convert this double or integer to character. For example, if rename, for example. So in our rename, we want to pass an integer number, and what we want to happen is that inside the function we want to have a sequence of if or switch that checks if the number is from 1 to 10. We want it to return the number, for example 1, that is multiplied, or of course now we're talking about the class. So a class can have an instance. Yeah, it will get ugly, but a class A can have an instance of integer, and if we want to convert that integer to something, we can basically there getters and setters that we can use and convert it to something else. Basically the same as just writing down that we want this to be equal to, for example, 1 and 1. And in this way we don't return anything because there is nothing that we want to be returned. We just want to convert this one into 1 1, and because this will be kind of a sequence which in a linear way should explain if there is a change in the class. Just imagine if we have a car and it has problems inside the car, and sometimes you just trigger something that would decrease the amount of liters that you have inside your car, and at one point it triggers that you need to go for a gas, then this one would be triggered to 2. So then something like that would happen. So whatever. So the higher order functions is that we can, in this these are, let's revise, these are formal factual parameters. If they're factual, if they're the ones that we call. For example, if we call ren with 10, this is a factual parameter, or this 10 is equal to 10, and we call a here. So what is this is a factual, this is a formal. So imagine that we want to pass a different kind of function inside our function. Well, how would that happen? Well, easily enough, we just can write a whole function inside our function, right? And what will happen is that we have our storage, and inside, I already said that we will create a new body for our function, and inside this body, when this is created, it will check and it will see that there is another function to be called, so it will create another body, and everything like that is going to be just like a leaf, and leaves, you know, continue and on and on and on. So it will continue to create more more bodies for more functions. But how exactly do we do that in practice? All right, it's easier said than done, but let's check what a predicate function is. So a predicate function is a function. A predicate function is a function that basically returns true or false. So each and every function that looks bool. So each and every function that looks like that, bool, and it's basically odd, and it gets us value of, let's say, int number, and if number is equal to 2, return we can make it even easier, just for the sake of not wasting time. You check what that is, but basically return. So if a number is if 1 is divided by 2 and it's not 0, then what would be returned? It will be returned false. So odd will be so the return value will be return. You can see that if this whole thing is true, then it will be odd. So basically, if that is false, it will return that it is not odd. So we have to kind of reverse it. So in order to reverse it, as you can see, we have to write that this is even. So inside a function, what we can do is, when we call the add, and we want to add only if int number, and we want to add this function, then we might want to have a certain amount of function that kind of checks if it looks like the function even. All right, so Now you understand how this part over here and the magic here happens. Before we get to the part of recursion and what recursive structures are, it's good to mention that there are also the so-called lambda function, which are kind of functions that they don't really have they don't really have a name, so they're just there, but we can check what their vision if in advance is, so what they can see from outside the function, such as that we can declare them like auto add, and this way this is going to be equal to a function that uses two variables, int a and int b, that combined do something inside the body, which is pretty cool because you can use them in many places without actually wanting to call a name of a function, and they they can be imported such that they are seen from the scope of the place where we use them, and if something checks for a function, which is the last thing that I'm going to say in terms of higher order functions, because it can get really messy, I'm just going to write it down. So int I, int j, and int function int and int. So this is the last thing that I'm going to mention, and it basically shows that we can use this so that this function over here, we're saying that we're going to need such function inside this function, and basically we're going to require something that looks like that, and you can see we have a reference to a function that should have an integer and an integer inside. So for example, inside this operate function, we're going to return the function that is called funct, and inside we might need the I and the j from over here. And in this way, we basically want us to create a block of memory that requires a function inside that is going to create a block for another function. Well, I hope that made some sense, but if not, feel free to ask questions. But this is very strong and important to know, because in this way, maybe we forgot to mention, but functions are actually created in order to save us some time. We need to save some time from writing repetitive code, or we might even write something that we don't know it should exist, but it should exist in some time in future, or if there is something that is already implemented in such a way, we're going to require it and extract it and use its functionality inside another function that has specific needs, because it's very good to know that one of the approaches, if you're not familiar with it, is to divide everything so that everything has only one purpose. And this way we might need a certain amount of functions that do something for different types of variables and have logic that, based on all of that, creates a finite state machine, for example, that can accommodate different inputs, which is extremely important and something that you should definitely watch out for and dig deep into it if you want to work with it. Okay, so let's say that was everything that we want to say about functions, and now we'll see how they work in recursion, because recursion is definitely something very important, and it's based on functions most of the time. All right, so what is a recursion? Well, you might have heard it. It's pretty easy and straightforward to know what a recursion is, and a recursion is a function that calls itself. Well, it's a little bit more difficult than that, but pretty much that is it. It's a method that can at some point call itself and continue and expand its tree. Okay, let's take a break here before we dive into what recursion is and recursive structures.